Dynamic programming was invented in the 1950s by Professor of Mathematics Richard Bellman to solve optimization problems in new ways that took advantage of the computer's processing abilities. It's a general technique to design algorithms. It can be used on a wider variety of problems than more specialized techniques such as greedy or divide and conquer. Dynamic programming can be a difficult subject for students to grasp, partly because it relies on a good understanding of recursion, and also because it requires the student to break down the problem into subproblems. And in the more advanced cases, it's not always obvious exactly how to do that. Now, there are many excellent textbooks that teach dynamic programming in a very comprehensive way. And there are lots of engaging online resources and tutorials on the subject that present aspects of dynamic programming. But I wanted something that combines the best of both textbooks with the fun tutorial style. So an article by Michal Fodishek, 2015, caught my eye. The article is called Towards a Better Way to Teach Dynamic Programming, and in it, he sketches 8 lesson plans with an innovative step-by-step method to help students get a solid foundation of dynamic programming. I decided to bring this article to life as an online course, actually, as a series of Jupyter notebooks with embedded videos, quizzes, and coding exercises. The core audience is OMS/CS students who want to prepare for the course Graduate Algorithms. My intention is that students can complete this preparatory course in a few hours or over a weekend. The notebooks are still in early stages of development, but let's have a peek at what there is so far. Before I switch over, note 2 important links in the description of this video. There's a binder link to the published notebooks in their current state on their GitHub repository, and a peer survey to fill out to give me some constructive feedback. This is the first notebook. It's a prequel to the first lesson in the Fodishek article. The purpose is to provide a review of recursive algorithms. You can watch this short video directly from the notebook and give me feedback. Here we have a quiz. This is a work in progress. I'm working on adapting some nifty code I found to present interactive quizzes in the notebook. And here we have coding exercises. I'm working on a way to hide and show solutions. Currently, the only way I've found doesn't export well to Binder, so for now I'm putting the solutions at the bottom. I use LaTeX to format it, so at least I get a link which allows the user to jump to the solution and back. This is the second notebook. This is lesson 1 of dynamic programming. We start to take a look at calculating the nth Fibonacci number. Here I set the foundation for the 4-step method laid out in the Fodishek article. A word about how the videos and also this video were made. I have 0 experience in creating videos, and this was a big challenge and unfortunately consumed most of my time during this milestone. However, I believe I found the tools and a method which will allow me to speed up content creation going forward, and I'll share it with you briefly for feedback. I used the scaffolding technique, where first I write the script, and then I record it. After much trial and error, false starts, and hardware issues, I found this combination of tools works for me. A paid version of Screencast-O-Matic for writing the script, recording the narration, and screen recording. I use PowerPoint to create slides. While Screencast-O-Matic plays back my narration and captures the screen, I click through the presentation in time to the audio. Then I also use Screencast-O-Matic to do some light editing, such as cutting out silence, speeding up the video, adding graphic overlays, etc. I then use Lightworks video editor for other touch-ups such as audio quality. So to summarize this milestone report, to see the magic in action, click on the binder link in the description of this video. Without setting anything up or installations, you should be able to interact with the notebook right from your browser. And finally, there is also a link to a peer survey in the video description, which I will be very grateful if you will fill out. Thank you for watching, and good luck on your project too.